Okay, so we continue. Uh, of course, this video is made specifically for my online learners, those that have got science. Now, recently we've been looking at current electricity, and so we want to answer this very simple question here. So follow me. We are saying the figure below shows some resistors connected to a 24 volts battery. So we have got these three resistors that are connected to that 24 volts battery. We are saying calculate the effective resistance in the circuit. How do we get the effective resistance in this circuit? Now, if I may ask, is this a parallel connection or a series connection? Okay, it's neither, but instead it's a combination. It's a series parallel connection, right? It's neither a parallel nor a series connection. It's a combination of both. So what do we do here? How do we get the total resistance when we have something like this? Now, what we do here is that we first of all deal with these two resistors. You will agree with me that these two resistors are in parallel. They are in parallel, so we are first of all going to deal with these two. Now look at this. When we deal with these two, when we find the total of the two, for example, let's say the total of the two is 3, for example. We are going to have something like this. We are going to have this 2 ohms resistor and the total of the two. The total of these two, for example, it is 3 ohms. You've seen that? So the total of the two resistors is going to be in series with this one. So to find the total resistance, after we deal with these two, the answer that we are going to get, we are going to add it to that one. So we are saying that the resistance will be equal to, we deal with these two, R1 times R2 over R1 plus R2. Because these two guys are in what? Parallel. No wonder we are doing that. So the resistance, the total resistance of the two will be equal to R1 can be 3. So we say 3 multiplied by R2 is what? 4 over 3 plus 4. So we are going to have 12 divided by 7. And so when we say 12 divided by 7, 12 divided by 7, we are getting 1.7. So 1.7 is the resistance, the total resistance of these two. So it's more like we have something like this. We have this 2 ohms resistor and a 1.7 here. You've seen that, huh? And a 1.7 of the two. So to now get the final answer, we are just going to add these two. So we are going to say, therefore, the total resistance now will be equal to R1 plus R2. So the total resistance will be equal to R1 is 2 there plus 1.7 ohms. So the total resistance will be equal to 3.7 ohms like that. That is going to be the total resistance. Question B is asking us to calculate the total current flowing through the circuit. Now, how do we get the total current? Feel free to pause the video and attempt the question. So, to get the total current, we go back to Ohm's law, where we are saying that resistance is equal to voltage over current. Now, because we are looking for the total current in the circuit, we are going to get the total resistance and the total voltage there. So what is the total resistance? It is 3.7. What is the total voltage? 24 volts. So the total resistance, 3.7, is equal to the total voltage, 24 volts, over the total current that we are looking for. And then from there, we are going to cross multiply. So 3.7 times current, we get 3.7 current equals 1 times 24, we are getting 24. Now when we divide both sides by 3.7, when we divide both sides by 3.7, the total current flowing through the circuit will be, that is 6.5. So we are getting 6.5 amps. Don't forget the units. Amps. 6.5 amps. Question C says, draw a voltmeter across the 2 ohms resistor and find its reading. Now, what is a voltmeter and what does it do? What did we say, Abigail? Now, we said a voltmeter is an instrument that is used to measure voltage in a circuit, right? So they are saying the voltmeter is supposed to be drawn across the 2 ohms resistor, this one here. From the notes that I gave you, we also said that a voltmeter is always connected in parallel with the component. So in this case, the voltmeter is going to be drawn like this. It will be drawn like this. Say V there, then we do that. That is the voltmeter. If we want, it can be drawn outside there. It's okay. So this is the voltmeter. Now they've said, and find its reading. They want the reading of the voltmeter, meaning what is the voltage here? What is the voltage here? Remember, a voltmeter reads voltage. So because they want the reading of the voltmeter, that's what the question says. Draw a voltmeter across the 2 ohms resistor and find its reading. We have drawn the voltmeter, but then what is its reading? So recall, from Ohm's law, recall that resistance is equal to voltage over current. So since they want the voltage here, what is the resistance here? It is 2. So where there is resistance here, we're going to put 2 equals, what is the voltage there? It is what we are looking for, over the current. Remember, current flows from positive terminal. So we are still going to have a current of 6.5 there, because when it reaches here, it is still 6.5. It is here where the current is going to branch off. Okay, it is here where it is going to branch off. Part of it, we use that route, part of it, that route. But here, the current is still 6.5. So where there is current here, we are putting 6.5, and then we say over 1 and cross multiply. Now, 1 times V, we are getting V. So what is 6.5 times 2? We get 12.9, right? 6.5 times 2, we get 13, eh? So we get 13. So 13 volts is the voltage across the 2 ohms resistor. Now listen, if we have 13 volts here, there is 13 volts here. There is 13 volts here. So what is the voltage here? You cannot say voltage is 24. This is not a parallel connection. It is in a parallel connection where voltage is the same at all points. What is the voltage across this? So to get the voltage here, that is not part of it. We are done with the question. I'm just trying to talk about something else. So what is the voltage across this 4 ohms resistor? So to get the voltage across this 4 ohms resistor, we say 24. You've seen the total voltage, 24 minus 13. So that is what? 24 minus 13, that is 11. So across this 4 ohms resistor, we have 11 volts. Now these two are in parallel with each other. So if there is 11 volts across this, then across this, there is also 11 volts. Okay? So if we have 13 volts there, to find the voltage there, you say the total voltage minus that 13, which gives us 11 there. So there is 11 volts. Across this, there's also 11 volts. Why? Because these two are in parallel. So in a case where we are supposed to find the current flowing through the 4 ohms resistor, we would first have to find the voltage there. Okay? How do we get that? Just what we've done. Yeah. Okay, we'll continue. Bye-bye, guys.